Hi, this is Stuart. Today, slow down. How to tell if your project needs to slow down. Here's a hint. Probably does. If you divide the number of points in bugs, the number of points in user stories in any interval, so it could be if you're on sprints, do a sprint, or a week, or a month, doesn't matter. It's a ratio. The time component cancels out. If that's greater than 40%, you're going too fast. If you run Linter findings and you normalize the count by dividing by the number of thousands of lines of code, by the way, this doesn't matter what the programming language is or whether you use tabs versus spaces or blank lines, it's gonna tend to the statistical mean. So if you have any critical findings, that's a problem. If your number of high findings are greater than 1% per 1,000 lines of code, that's not good. And if your mediums are greater than 3%. Healthy code has no linter findings because as people code, they fix it as they go. That way your code will never give you whoa. Pull requests or merge undos greater than 1 in 10. If you do 10 merges and you have more than one failure per 10, you're going too fast. If your pull requests impact more than 200 lines of code per pull request, you're going too fast. You're also having way too much granular change per interval of merging and continuous deployment. If your average branch time exceeds 2 working days. Now, if those of you who are doing trunk-based development and have a no overnight branch rule or a no greater than 4-hour branch rule, you probably don't have to worry about this. But if you're doing traditional development, this is a stinky thing. Every study that's ever been done on branching shows that long-lived branches make big messes. If your unit test coverage is less than 80%, above 80%, or, between 80 and 90% is the sweet spot, trying to get to 100% actually causes people to be so frustrated they make stupid test cases. A stupid test case is any test case that doesn't actually test anything. So tests, for example, that don't seem to have any assertions in them, or test cases where if the test doesn't explicitly fail, it passes, or test cases that are so contra-wired, so fakered, so stubbed out, so whatever, that it's actually not exercising any reasonable amount of actual business logic. These are all stupid tests. Don't test stupid stuff. In fact, do risk-based testing. Anytime your deployment failure percentage is greater than 0.5%, you're going too fast. And this is deployment to any environment. Dev, QA, UAT, perf, stage, whatever, prod, especially prod. Boy, if you have prod deployment failures, you have a big problem. In fact, I'd say any prod deployment failures are a problem. Story points of bugs found in production versus story points in the last deploy, greater than 1%. And by the way, this should be tempered by severity, because if you find a whole bunch of low severity bugs like weird spacing or, spelling errors, those are lows. And so, they're a lot less worrisome. Any critical or high severity bug in production, though, is a huge deal. You need to figure out what happened that happened. And if it transpires that the reason you have that problem is because the data in production is so different in kind, quality, or measure to the data in the lower environments that no amount of testing in the lower environments would have found it, then you need to find a way getting a subset of production data that represents the actual use cases cleansed and flown into the lower environments so that they're there. Or you need to create test data that mirrors the data in production that caused the problem. One way or the other. Yeah, and this is particularly a problem where a lot of the behavior is metadata or rule driven. Find bugs because the metadata or rules in production don't, of kind, quality, or action, match those that are found in non-production. Every single high priority severity business case should be tested. 80% of the medium ones should, and a spattering of low ones. Do risk-based testing, in other words. When you're trying to decide, do I write test A or test B, as a developer or a QA, you should be deciding based on severity and, to some extent, secondarily coverage. API test coverage. Anything less than 100% on every single method is unacceptable. If you're putting an API out into the universe, you need to test all of the methods. If for no other reason, then the tests on the methods of your API serve as a really useful piece of documentation for your API. You need to validate 90% of the validations, 80% of the exceptions, and at least the most common unhappy paths. Again, risk-based testing. Library vulnerabilities. You should not allow criticals. You should not allow too many highs. And the highs should be marked for next release remediation. And thus, again, we're going at this from a risk-based basis, right? But you should not tolerate library vulnerabilities unless you determine that it's a big, spacious library and the bits that are vulnerable are not the bits that are using. Problem, of course, comes with how do you know that? Because you could have a library reference for a library that you're using, and that library reference is actually used by a library that's used by a library that's used by a library that's used by a library of that library reference. And it has a vulnerability. And so trying to figure out whether or not that is actually a problem for you can be a little tricky. Tools help. There are lots of good tools that will do that. Some are open source, some are commercial. The commercial ones generally have the advantage that they have a huge metabase up in the sky somewhere of all the vulnerabilities and use and a lot more use cases. Any use of unsupported libraries or unmaintained libraries. So if you haven't seen a change in 6 months, there isn't a new version, or if it's a continuously built thing, if there aren't any changes for 6 months, that's a worry. So what do you do to fix these things? Here's the obvious one. Your PRs are too damn big and you're not testing enough. Slow down, make smaller incremental changes, and make sure that they have tests. Consider the context of your changes. Right? You're working on something and it's going to be consumed by something else, because almost everything's consumed by something else, even if it's only a user. If something throws an exception, what does it impact? And that covers whether or not the exception was intentional, like a validation exception, or unintentional, like a weird runtime exception. Parenthetically, if you're looking at your runtime exceptions and you see any of the lazy exceptions, so that's null reference exceptions, out of bound exceptions, range exceptions, type conversion exceptions, that's a symptom your code is not very good and you need to slow down and make that code better. Those should never, ever happen. On the other hand, out of memory exception because the server had, a severe problem, that's not your problem. So understand which exceptions are about coding quality and which exceptions are about failure to consider use cases, and which exceptions are just inflicted on you by your runtime environment because you can't do anything about it. What happens if an optional parameter is not passed? Is there really a happy path? What if there are multiple optional parameters and they're not passed in combination? Did you consider that? Do you have an overall validation that looks at the state and says, if this validation passes, there is a happy path through my code? And is the change you just made testable? How would you write a test for it? That's why the test-driven development people and those of us in the test with development community are really big on a pull request should always have the tests in it. You shouldn't have a pull request with code and a different one with tests. You should make a little change, write a bunch of tests, and make that the scope of the pull request, where the tests passing are partial proof of your good intention and execution. Do you handle transient failures well? One of the things I see people doing all the time is they put a transient failure library and they wrap it around some connection to the outside world, to another service, to a database, whatever. Doesn't matter. In 12-factor, it's a dependence. But they don't handle what happens if it just simply cannot recover within a certain number of time or retries or whatever. What happens next? What happens to the unit of work when it failed? A lot of people code but don't build unit of work patterns, so there's no clean way to recover and restart the unit of work. I have a lot to say about that in my various videos on queuing and leasing and units of work. Validate inputs. It's astounding how many errors in production are because when they developed it, no one would have considered putting the word frogmore in a box that is asking for 1 to 10. You simply cannot trust, not from users, not from other systems, not from anybody. The majority of your validation should be at whatever your API tier is. Yes, you should have validation on your user experiences or whatever, but if they're just using your API out of the box, it ought to do validation at the very least. And they're for two different purposes. Validation at the UI is to help people data enter better, and validations at the API is an anti-corruption exercise, which is an important part of domain-driven design and well-architected systems. Fix the linter errors. It's trying to tell you something based on the severity in your policy. I mean, this can be juked by juking the policy. A lot of linters allow you to embed a comment above the thing that says, don't call this out. If you were the one reviewing the pull request or doing a code review, you should be deeply suspicious of these. But fix the linter errors. And by the way, almost all of the linter errors that you get running the command line will now show up in a modern IDE. Doesn't matter what your IDE is, right? Eclipse, VS Code, Visual Studio, whatever. They integrate the linter, whatever linter you've configured, into your IDE, and they put little symbols next to the line of code that goes, this is not so good. And you shouldn't ignore those. I have watched developers type lines of code, immediately get an error that says this is terrible, don't do this, and have them just ignore it. The way to get close to low defect code is to start with the low-hanging fruit, which is what linters provide. Address the static security scanning errors, right? If you're running, sync or one of those other tools, and they kick out a security error about your code, you should pay attention. Those things are pretty bright, and they're context aware, and they are capable of producing pretty useful outputs. So if you don't understand the output, get some help. But in all cases, again, by severity, in other words, doing risk-based development, you should stomp those flat. You shouldn't say, we're going to do those at the end of our PI, or we do those on the second Friday of every sprint. No, do them now. Now. Improve unit tests. We talked about what makes a dumb unit test. When I peer review a piece of code, the first thing I do is go look at their tests. If their tests are terrible, I'm going to assume their code's terrible too, and I'm almost never wrong. Prove integration tests. There are a bunch of things you cannot unit test. Does this subsystem play nice with that subsystem? The only way to test that is integration. They're hard. If it was easy, they wouldn't pay you as much money. Pay attention to integration tests. By the way, automated integration tests are what QA should be doing. If QA is doing manual testing, you are wasting their talent. Just say no. Unless they're doing exploratory testing, which is okay. Tests should be automated. Embrace and extend teachable moments. Doing a code review and it's not very well laid out or structured. Take the extra time to get the developer on a screen share, or sitting in the same cube is even better, but at a minimum on a screen share, and go, if we restructured this and this and this, and do the refactoring with them right there and show them how it's better. How do we know it's better? It's testable. Each part is separated from the other part. There's a separation of concerns. In other words, solid, right? When you're doing a code review, look for solidity. When people break solidity, it's a teachable moment. Stop and teach them something. And if you're a lead, that is a deeply held belief that is your number one obligation. You're a lead because allegedly you're a better coder. So teach some people some things. My name is Stuart. Thank you for your kind attention.